So again, just a little reminder, this one we're using only elimination. And we've got a new system. And again, I'm going to label my equations 1, 2, and 3, just so we can track them as we go and keep it a little bit easier for ourselves. So we want to eliminate something here. I'm going to start with equations 1 and 2. Just because I see that we have that negative z and that positive z right there, so I know that they'll cancel out nice and easy for us. So I'm going to copy those two equations down. And let's add them together. So we'll get 2x, or 3x, plus 3y is equal to 2. And we're going to call this one again equation 4, because we now have an equation in terms of two variables, which is what we want to do here. So again, let's see, we can get rid of that negative z and that positive z with our equations 1 and 3. So let's just do that same process again with equations 1 and 3, where we have x plus 2y minus z is equal to 4, and x plus 2y plus z is equal to 2. Now adding these together again, we'll get 2x plus 4y is equal to 6. And now we have equation number 5, another equation in terms of just x and y. And let's make a new smaller system again. 3x plus 3y is equal to 2, and 2x plus 4y is equal to 6. Equations 4 and 5. Now we have another system with two equations and two variables, which is much easier for us to work with. So let's again stick with our elimination, and we'll try and eliminate one of these terms here with equations 4 and 5. So I can see with 2 and 3 for our x coefficients, we can just multiply them by one another and make one of them negative. That way we can cancel out our x terms. So I'm going to multiply equation number 4 by 2 on both sides, and equation number 5 by negative 3 on both sides. Now we'll get two new equations here. We have 6x plus 6y is equal to 4, and negative 6x minus 12y is equal to negative 18. And we're going to add those together. So we can say we'll get 0x, and then we'll be left with negative 6y is equal to negative 14. And we'll just divide everything by negative 6 here, which leaves us with y is equal to 7 over 3. Now we've got our y, which we can plug back into either equation 4 or 5 to find x. I'll use equation 4. And that's just because I noticed we have 3y here. So these 3's will cancel out nicely. We'll get 3x plus 7 is equal to 2. Subtract 7 on both sides, and we'll have 3x is equal to negative 5. And once we divide by 3, we'll be left with negative 5/3 for x. And the last thing we need to do is plug in our x and our y and find z. So going back to equation 1, I'm just plugging in each term that we do know. It's equal to 4. And then we're combining our fractions here. So we've got negative 5/3 plus 14 over 3 minus z is equal to 4. That becomes 9 over 3 minus z is equal to 4. which is, this is just 3 minus z is equal to 4. Then we can say z is equal to 3 minus 4, or z is equal to negative 1. Now we have all three of our terms, so let's just put them as our point for our final answer here. We have 5/3, negative 5/3, positive 7/3, and negative 1, giving us our final solution there. So that was a quick reminder on how to use algebra to solve these systems. But as we move through this unit, we're going to be talking about how to use matrices to find solutions for systems, which are going to be actually a little bit more of an easier tool in the end. They might not seem so at first, but as we go, I think we'll be able to move along fairly smoothly. But I'll leave that for our next video, which will be coming out fairly soon. So I'll see you all in a little bit.